Hi everyone, today we're going to take a look at nodal analysis. It is a method that allows us to analyze circuits using node voltages as a variable. It's based on the Kirchhoff's current law, and there's some steps that we need to have a look at before getting into a question. Step number one is determining the number of nodes within a network. Step number two is picking a reference node and labeling each remaining node with a subscript value of voltage V1, V2, V3, and so on. Now, step number three is label the current directions and polarities. Step 4 is where you apply the Kirchhoff's current law to each non-reference node. And step 5 is solve the set of system equations for the nodal voltages. Let's have a look at the circuit here. So here we have a circuit with 20 volts. R1 is 4 kilo ohms, R2 is 5 kilo ohms, and IS is 4 milliamps. So our first step was labeling all of the nodes. So we've got a node here, which is I1. Sorry, that's just meant to be 1. And we've got a node here, which is 2. We've got another node here, which is 3. Now we need to pick a reference node. Our reference node, we can just actually make that our reference node, and that's our ground. Now we need to write the subscript value of voltages for the rest of the remaining nodes. So that's V1, that's V2. Now we need to label the current directions and the polarities. So that's just positive. That's also positive. Here we have negative and negative. So now we got I1 coming into the node, IS coming out of the node, and I2 going out of the node as well. Now we need to solve the equation using Kirchhoff's current law. So now Kirchhoff's current law is we go I1 minus I2 minus IS equals 0. Now we need to represent that in terms of the voltages, so that we have V1 minus V2 over R1 for I1. For I2, that's just Ohm's law, so we have V2 over R2 equals IS, and we take IS on the other side. Now V1 over R1 is just 20 over 4 volts, because that's our V1. So that gives us 5, and that's V minus V2 over 4. And now minus V2 over R2 is minus V2 over 5, and IS is 4 milliamps. Now, taking 5 to the other side, that gives us negative 1, and we can take out negative V2 as a common factor, so we're left with 1 over 4 and plus 1 over 5 inside the brackets. Now, the negative V2 and the negative 1, their negatives cancel out. So now we're left with V2 times 9 over 20, and we made the denominator same over here, equals 1. Now, 1 divided by 9 over 20 is basically 20 over 9, so V2 is 2.2 volts. And that's how you solve a nodal analysis problem. Thank you for watching.